Good morning. Today we'll be dealing with solving exponential equations using logarithms. To This time we'll be making sense of problems to solve them using critical thinking and technology using our TI-84 calculator and also using our Desmos in here. Now, let's go to our graphic organizer for this case first. So as a review, we say that exponential a to the b equals c, where a is our base number, b is our exponent, and c is our answer. This can be expressed in logarithm as follows. That's logarithm base a of c is equal to b, which means that the base number a will be the base subscript a in the logarithm. The exponent b will be our answer for the logarithm, and the answer c in our exponential will be the value c in here on our logarithm. And as we may see, any growth or exponential growth and decay equation of the form a equals p times 1 plus or minus r over 100 raised to the t power will always be in exponential, which means that if you want, or if we want always to solve for the time or the exponent, then we have to express this particular exponential in terms of logarithms. Once again, our a is usually our future or our present value. Our p is our principal or initial value. It's a plus if it's an increase or growth, minus if it's a decrease or a decay. R is the percent rate, and t is always the time, whether that be in years, seconds, minutes, hours, and so on. And again, the r is always divided by 100 to convert automatically the percentage rate into a decimal or its decimal value. Let's read our first problem and use our cubes to analyze this particular problem. It says you bought your home for $420,000 and its value increases each year by 8%. Approximately how many years will it take for the house to be worth 600,000? So this application is on investment. In this case, the price of a house. Let's circle the numbers: 420,000, 8%, and 600,000. Let's underline the question. And the question is, how many years will it take the house to be worth 600,000? Let's box the keywords. 420,000 is the value the home or the house was bought. 8% is the rate of increase. We're talking about the number of years for the house to be having its future value 600%. So in this case, let us now make an equation out of this. So in this case, 420,000 is how much the house bought for, then that will be our principal value, 420,000. 8% is the rate of increase, so that will be 8%. And A, or the future value, is 600,000. And again, we are looking for time t. How many years will we have to wait until it reach 600,000? Let's now plug in everything on this particular exponential growth equation. Then we have the following: 600,000 is equal to 420,000 parenthesis 1 plus, so we're using plus because it's a rate of increase, and that will be 8 over 100 raised the t power. And again, we're solving for t in this case. So in order to solve for t in this case, the first thing that we need to do is to remove the 420,000 in this case. In that, with that being said, we're going to divide everything by 420,000. And obviously on the right, it will cancel out. And let's figure out what will be the answer in this case. In solving this case, I can actually cancel the four zeros from the 600,000 and also the four zeros from the 420,000 and simply do a simplified fraction form for 60 over 42. Now let's use our calculator for that. So how to simplify a fraction 60 over 42? What we're going to do is to press alpha, press y equals, and then press enter. And then type in 60, press down to put 42 in there, and see what we'll get. That's 10 over 7. Again, I'm not dividing 600,000 over 420,000. I am simply doing its simplified fraction or expressing its simplified fraction because I want to get a correct and exact answer in that case. So again, that's 10 over 7. So I'll put it in here. Once again, I have the following in here now. 10 over 7 is equal to 1.08 raised to the t power. So once again, this is my simplified form for this exponential function or exponential. What I'm going to do with this case is express it into its logarithmic form. So in this case, on how to do that, then I can write this one as follows. So once again, in here, I can just put it in here as a to the equal c, where my a is 1.08, my b is t, and my c is 10 over 7. Now, how to write this in terms of its logarithmic form? Then it should be of the form, once again, for logarithm. Logarithm base a of c is equal to b. So in this case, this now can be written as follows. Logarithm base a, in this case, my a is 1.08, of c. My c is 10 over 7. I'm just putting it on inside a parenthesis just to make it clear. And is equal to the b. The b is in fact my time. Okay, so on how to solve for time, let's now use our TI-84 calculator for this case. Again, that will be the following. Log base 1.08 of 10 over 7. Now, on how to use our TI-84 calculator for logarithm. So this is what we're going to do. Let's press math first. After pressing math, let's go up until we see a log base. And as we may see, the log base is this log base in here. Type in enter. And there we go. We can put our subscript. Our base is 1.08. 1.08. And then we press right so that we go inside the parenthesis, and I'll put in there 10 over 7. So in this case, I can put a fraction, alpha y equals enter for our fraction, and I'll put 10 over 7 in that case. And let's see what the answer will be. That'll be 4.63 in there. Again, 4.63. So in this case, how long or how many years will it take for the house to be worth 600,000? The answer in here is this one in here. It would take approximately, so that is the symbol for approximated value. T is approximately equal to 4.63 years before the 420,000 value of the house can become 600,000. Let's have our second problem in here regarding population growth. It says the population of Canada in 1999 was 31,006,000. If the population grows at 1.2% per year, determine approximately how many years from 1999 it will take the population to reach 40,000. Assume the population will continue to grow at the same rate. So we're doing our cubes once again. We have already encircled the numbers, underlined the question, what is being asked, and box the keywords. Let's now go to E to evaluate this equation and solve for that particular equation. So once again, this is population growth. In this case, we're going to use our formula. A is equal to T, parenthesis 1 plus R raised to the T power. And once again, we're looking for the time in this particular case. So our A is 40 million. Value is 31,006,000. My R, or the rate of increase, is 1.2%. And again, we're solving for our T, the time it will take for it to be 40 million. So in this case, we're going to plug in all of the values in here now as follows. So that'll be 40 million is equal to 31,006,000, parenthesis 1 plus 1.2%, so that's 1.2 over 100. Sorry, I forgot the over 100 on the R. Raise the T power, and again, we're solving for T in this case. So what we're going to do first is to divide everything by 31,006,000. And instead of actually dividing it, we have to get the simplified or express this left side in its simplified form using our calculator. Let's use our TI-84 calculator for this particular. So we're using our TI-84 calculator now, and once again, on how to express any fraction into its simple form, let's press alpha, y equals, and then enter. Put 40 million above, and below, I'll put 31,006,000. And let's press enter now. So I got 1.29 in here as more or less my approximate value. Again, it's 1.29. 1.29 is equal to 1.012 raised to the T power. Again, that's the T power. So we're solving for T. What we're going to do in this case is to express this in exponential form. So again, we write it as follows. A to the B equals C can be written in logarithm as logarithm base A of C is equal to B. So in this particular case, my A is in fact 1.012. My B is my time T, and my C is the answer 1.29. Actually, that's approximately 1.29. So in this case, to express it in my logarithm, then it can be written as follows. Logarithm base A which is 1.012, of C, which is approximately 1.29 approximately, and that will be equal to my time, which is equal to T. Now, let's use our TI-84 calculator for this case, or we can also use our in this case. Let's use. So in using my Desmos for this case, what I will do is to press the following first. I'll press the keyboard icon, I'll press the functions, and I'll go to miscellaneous. And after click on the miscellaneous, I'll click on log base A in this case. At the subscript, I'll put 1.012, and inside, I'll put 1.29 approximately. And it says in here, I already got the value of 21.35. Again, it's 21.35 in this particular case. So that's 21.35 approximately in number of years, which means from 1999, 21.35 years is approximately year 2020. For now, you can work on your own on this particular problem about share or value of shares. Once again, let me know if you have questions regarding this topic about solving exponential equation by logarithm. Tell me, QUAN-do. You can do math.